Hi everyone, my name is Kajal and I welcome you to the fourth video of multi-threading series. Now, in this part, we will be talking about how you can create thread. Till now, we know that whenever you start executing this main method, one default thread comes into picture by the name called main thread, right? When you want thread, you have to create an object of thread, okay? And if you want to create an object of thread, we have a class by the name called thread. Whenever you want to create an object of thread, you have to call the constructor of it, right? First of all, I'll show you the constructors present in the thread class. What are constructor? Constructor is a method whose name is exactly similar to the class name with no return type. We use this constructor whenever we want to create an object of it, right? So I'll show you all the constructors present inside my thread class. So this is the constructor number 1, which is private. Private means you cannot call this constructor outside of this class, right? Let's come back to this private constructor after some time, but before that I'll show you other constructors. So now this, can you see we have a public constructor of thread class, right, in which do not have any parameters, but internally by somehow it is setting 4 things. The first one is the group. Whenever you're not telling what group you want to create this thread to, by default it creates a thread to the group from wherever the thread has been initiated. For example, main is one thread that is present in whenever you start your application by default. Now you want to create one more thread, so this thread will belong to some group, and if you will not provide name to that group, it itself says that okay, the thread group is main, from where the thread has been initiated. Then target right now is null. You can see the target is null. Then after there is something called name. So name means what? Now you have created a thread and you want to assign a name to that thread. If you are calling this method, the thread name should be thread hyphen and then it can be any number 0, 1, 2, 3, 4. So how many threads you have created, basis upon that thread number will be allocated. Then after you have something called stack size. The stack size is basically how much size or how much space you want to allocate to this current thread. If you are passing 0, that doesn't mean that the stack size is 0 or the space you want to allocate to this thread is 0, but this means it is calling some of the constructor internally. That's how you can create an object of thread class by not passing any parameter. Now you have another constructor of thread class in which you can only pass runnable, right? So except this target, everything is still same with the above constructor. You can see the group is still null. Target, because we are passing some target here, so that's why the target is going inside my target. So what is this target? Target is some object of runnable. What is this runnable? So if I'll show you this runnable is a functional interface. What is functional interface? Functional interface is an interface in which you will have only one abstract method. This functional interface can have n number of methods, maybe static or default methods with body, but this functional interface will only have one abstract method in it. Okay, that is mandatory. Without any abstract method, functional interface cannot be there. Right now, if I'll talk about this runnable, we have one abstract method by the name called run. So you can pass a runnable inside this thread object creation, and whenever you are passing this runnable, so the target will be whatever runnable you have passed, and except that everything will be same. We have this one more constructor in which you can pass this target. Also you can pass some access control context for some security purpose. For example, you want to give some access to something, so for that purpose this you can pass. This constructor is not public. Can you tell me what is the access modifier for this constructor? Comment down if you know what is the access modifier for this method. You have one more public constructor in which you can pass the group, you can pass the target, and the group and target will be whatever you have mentioned, and thread name will be the default thread name, and stack size will be again the default stack size. You can create thread only by providing the name. Let's say you have the custom name of any thread. You have one more public constructor where you can pass the group and the thread name as well. You have one more constructor in which you can pass this runnable, and also you can pass the name of the thread. You will have one more, the default constructor, in which you can pass the group, target and the name. You will have this the thread group, runnable, name and stack size. So whatever you want to pass, let's say you want to fix that for this thread, you are only allowing this stack size for one specific thread, then you can create that thread by passing all these values and by passing also the stack size to it. And this is one more constructor, so in which you can pass group, target, name, stack size. Also you want to inherit values from parent thread, then you can pass this inherit thread locals as true. This new thread that you will be creating by this constructor will have some local values available to the child thread from parent. These all are the constructors that are available for you, which any one of these constructor you can use in order to create the thread. I have shown you that we have multiple public constructors available in order to create an object of thread class. Let's see what internally they are doing. You can see this constructor which is taking the group and the target. If I click on this constructor is again calling one more constructor, which is the private constructor. Now let's see one more constructor. This is my constructor in which I'm only passing the thread name. Internally it is doing. If I click on this method, which is again a constructor, public constructor, and again this is calling constructor which is again private. My point is all the public constructors are dependent upon this private constructor in order to create an object of thread. They are setting everything inside this thread class, and that's how the object of thread is getting created. Now let's say one thread has been created with all the things that you have passed. You can see it is setting the stack size, and this stack size, whenever you are passing the stack size as 0, it's not like that you are not giving any space to the thread. It's like you are going with the default configurations and you don't want to mention what will be the stack size. It will go with the default stack size for all threads. Then set the priority, it sets the target, everything will be set inside this private constructor of the thread class. You call a constructor of thread class which is public from any of your classes, and internally it is calling this private thread constructor only. When the thread has been created, at that time you would want to start the thread. Once the thread object has been created, now in order to start the thread, you call the start method, and it's after doing some basic validation check inside this try block, it is calling this start 0. So if you will see this start 0, the private method with a native keyword. What this native keyword represents? Whenever you see the native keyword with any method, then you can understand it like the JVM is going to interact with operating system, because JVM cannot create a thread only on its own. JVM has to communicate the same thing with machine first. Let's say your machine has only limited resources and you're not able to create a thread, then alone JVM cannot create the thread, right? This native keyword represents JVM has to get connected to operating system in order to start the thread. You can create object of thread by creating the object of thread class, but then after JVM will be going to operating system to check whether we can start this thread or not. This start method implementation is not there. JVM starts it after the communication with machine, and then machine calls this run method. Inside this run method, it says if target is not equals to null. What is this target? If I'll show you this target is the runnable and you are passing runnable in it, then in that case this run method will be calling the run method of runnable. There is only one condition: if target or the runnable that you have passed while creating the thread object, if the target is not null, then this run method will call the run method which is present in my runnable interface. In the next video, I'll tell you how you can create the object of thread class. Thank you so much for watching.